Hello, welcome. My name is André. I am post-graduate student at the University Federal of Pelotas, and today we are to talk about my research study of background of the polycrystalline structure MgMOO4A2O, or hydrated magnesium molybdate. My presentation will be conducted as follows: introduction, importance of research, methodology, magnesium molybdate, results and discussion, results XDR, results thermogravimetric analysis, conclusions, acknowledgement, and reference. Introduction, importance of research. Why research? We researchers look for ways to make the lives useful and powerful that develop materials with possible innovations. In this research, we seek to carry out a studied physical-chemical properties of the material magnesium molybdate. For the future purpose, photovoltaic application. We can see in the background the solar panel. This is an example of application. Why work with molybdates? We started to study metallic molybdates due to their technological importance in variety of applications, such as ionizing radiation detectors, matches, or optoelectronic devices. We can see in the background image the molybdate magnesium synthesized by me and the unit cell parameters. This image is obtained by software Vesta. In this research, we used some analysis techniques and laboratory instruments such as microwave-assisted hydrothermal in the figure, X-ray diffraction XRD, and thermogravimetric analysis TD, the third image. And the second is XRG, and first is MA8. Methodology, magnesium molybdate preparation, stage 1. To prepare the synthesis of the samples, the precursor sodium molybdate dehydrated and magnesium chloride exhydrated were used, which underwent the homogenization process through a magnetic circuit, with the variations in water concentration and ethylene glycol concentrations. For the stage 2, soon after, the pH of the solution was controlled, trying to identify whether the compounds had the pH 7. This is due to results obtained previously, in which the synthesis was successfully performed with this pH. In stage 3, we have the microwave-assisted hydrothermal method, where the rating was chosen to perform the synthesis, where the pressure and the temperature were observed. Stage 4, separation of residues. Separation of residues of the samples was carried out through the centrifuge, where soon after the samples were prepared for drying. In stage 5, the spectrums were obtained and analyzed. The main results observed in relation to the structure of the samples were identified. In this stage 6, we have the thermal analysis of the samples was performed with the phases obtained from the magnesium molybdate. Results XDR, sample A001, physical parameters, pressure and rating rate. The results obtained for this sample demonstrate that there are two simultaneous phases. The phases are related to the hydrated and dehydrated magnesium molybdate composition, dehydrated and hydrated form. The spectrogram has composition of multiple crystalline planes related to the plane corresponding to monoclinic and triclinic form. We can observe that the hydrated phase has more intensity in the sample A001, demonstrating that for these parameters, we obtain the hydrated phase more easily. Another result related to the change in intensities of some diffraction peaks is reported, demonstrating that the synthesis through the hydrothermal method assisted by microwave influences the preferential growth of the crystallographic planes Note that in the plants 001, 002, 1, -1, -2, 003, we have that the index is becoming greater in relation MgMOO for A20, the clinic phase, demonstrating the preference in the growth related to the crystallographic orientation. Results thermogravmetric analysis. Sample A001, mass loss 18%. For the sample, we have the monoclinic and the triclinic phase. In this result, we have the mass loss corresponding to published scientific article, demonstrating that the compost synthesized was rarely hydrated magnesium molybdate, and we can see that from 30 to 400 degrees Celsius, we have the dehydration of the compounds that corresponds with the article. Results thermogravmetric analysis sample A005 mass loss 9%. We have triclinic farm, and in this result we have the mass loss corresponding to published scientific article, demonstrating that compound that was really hydrated magnesium molybdate 2, and we can see from 100 to 400 degrees Celsius we have the hydration of the compost, and that corresponds with the published article, sem amarrar para trás. Conclusion. Through the research, we are able to identify new data regarding the integrity of the synthesis material in relation to the in-depth analysis of the different organs and the preferential growth of the crystallographic plants. Regarding thermal analysis, we also identified that the synthesis compound has phase changes corresponding to the literature. For the future studies, we will try to perform other characterization techniques, such as scanning electron microscopy and visible ultraviolet spectroscopy, thus analyzing its photovoltaic properties. My acknowledgement to CMSU, Group CECAF, UFPEL, and CAPS. My reference, and thank you for waiting.